For the second problem that will use strings and recursion, we're going to try to find the longest word in a list of strings using recursion. So that means given a list like A equals ABC, AB, ABCDE, this function, when passed the list, should return ABCDE because this is the word with the longest length. I'm going to use the same strategy as from the tree video, and I'm going to show it. So this is just our function. So the first step, as with the tree video, is make your function work for the base case. So our base case here, we're going to assume the user cannot input an empty list into this because there's just no strings to even return. So we're going to assume the smallest a list can be is 1. In that case, the only element of the list has to be the greatest element because there are no other elements. So this should be the correct return value. We should just return the only word input into there. So now I'll test the function. This is a single length long one and it returns ABC. If I change this to maybe AB or sun, this should return sun. And so our function does work for when it has a length of 1. So now we have to make it work for in any case, no matter the length. So every list can be thought of to be made of a list of a single shorter element. For example, if you have a list of 3, that's really just the same thing as, so you have a 1, 2, 3, that's really just the same thing as 1, 2 plus 3. Right? It's just this list with 3 added on the end, which means every list can be broken up into at least just a smaller list. So that's where we're going to use the recursion, where I said assume your function works for every possible case smaller than the given one. So in really the case you're trying to prepare for, the one you're trying to currently program, shouldn't actually have a number attached to it. It should be random. But just to make it easier to visualize, you can maybe just give it a number, like assume the list length they're trying to actually make a solution for has a length of 4. But don't program it specifically for the number 4, or else your function won't work for anything else because you specifically programmed it for 4. So just like in math, assume that it's a random variable, the length of this list. So assume that this function, then we're going to try programming it for a length of 4. Assume it returns the correct value when given a list of length 3, 2, and 1. So if that's the case, then the longest word in this given list should be the longest word between, I'll give an example, ABC, ABCDE, and AB. So like I said before, this is actually just the same thing really as saying ABCDE plus AB. So the longest word in this list is either going to be AB or the longest word in this list, depending on which one's longer. So let's check. This one has a length of 3, this one has a length of 5. So in just this list, this one has the longer length. So then I'm going to compare it to this outer element. This outer element has a length of 2, this one has a length of 5, which means we're going to return ABCDE. So we're assuming our function works for 2, so then it's going to be just the same way. I'm going to use also list splicing too, so that way we can shrink our list. So I guess I'll call it other. Get longest word list. So this is going to find I want to exclude the current element. This is going to find the longest word in every element out of all the elements except the first one. So when passed this list, it's going to find the longest element excluding this first one right here. So really it's going to look at the list A, B, C, D, E, A, B, because it's excluding A, B, C, because I'm using list splicing here. So now that we have that, we just need to do exactly what I did down there. We look at the first element of the given list, and we see if it's greater than or equal to the length of the longest one returned from this. Because again, we're assuming that our function works correctly for any list smaller than our current list. This list right here is definitely smaller. It's smaller by a single element. So we're assuming that this correctly does find the longest word out of all those elements. Which, when we're joining it back together, the only thing we need to make sure is that the element we're adding, which in this case we're adding in A, B, C, we just need to make sure the length of that word is not greater than or equal to the length of the one found here. Because if it is, then that means this is the new longest word. So then, in that case, we've determined then that this word has to be longest. Now, of course, if that isn't true, that means that the word excluding this first one, there's a word in there that's longer than that one, which means that word has to be the longest. So then we just return that word. So now this is all assuming that our function works correctly for smaller lists. If we assume that, and if that is true, that our function does work correctly for smaller lists, then it will work. So using the same test as before, our base case is correct. We have a true relationship between a smaller version of the value input and the current version, the smaller version being a list of one element shorter. And so we have the relationship. That relationship should be true. We've assumed our function works for smaller ones, which means our return should be true, which means this function, if I give it the values, it should actually work. So once again, we can try ABC, AB, ABCD. And looking at this, it's clear to see that ABCD should be the return value, and it does. It returns the correct value. We can change this up to that, and that one's clearly longer. And now it returns that one.